Good afternoon. How's everybody doing? You having a good conference so far? Okay. A couple more sessions to go till the after party. Eh? You're still up for the challenge? Okay, wonderful. My name is Stefan Whittmann. I'm a product manager for many things, but I'll just say for interoperability in general. Everything that kind of goes in and out of the system is something that I look after. Python is one of the new additions that I've been looking at for a while now. And in this session, we're going to take a look at, well, what do you need to know and understand in order to be successful to get started with Python development on InterSystems Iris. First of all, since we have a couple of people in this room, let's start with some interactive entertainment. Who's been working with Python in the past? Okay, I would say that's about half of the audience. Who's been working with InterSystems Iris in the past? Oh yeah, that's more. So Iris is popular. That's nice. And who's a first-time attendee at this conference? Okay, so that's about a quarter maybe. Okay, wonderful. So in this session, we're going to take a look at a couple of things. First of all, we're going to get started with an overview about what are your options if you want to get started with Python development and get your data in and out of Iris. For a couple of these things, you actually have to do some setup and configure your environment and your system, so we're going to talk this through. Then we're going to take a look at interoperability in specific, so if you want to take care of the interoperability framework within Iris and orchestrate business processes, we're going to take a look at what your options are there. And then we're going to take a look at all the development tools that well, you typically need when you want to develop in that environment. So namely debugging and virtual environments, so sandboxing your code. That's the agenda for today, so plenty to cover. I'll be talking non-stop probably. First of all, why we are even talking about this, right? Python is a wonderful environment if you want to get started and work with data-heavy logic. If you want to visualize your data, if you want to do data mining, data engineering, then Python provides an ecosystem that gives you a lot of the tools already built in to solve these challenges efficiently. So Python is not just a snake, it's also a really nice environment. So while I was walking yesterday morning, right next door at my hotel at the Wyndham, they have a really nice lake in the middle. I was like, hey, this is really a nice environment. I'm feeling happy here. But there's always something lurking around the corner when you feel safe, right? I don't know if you can see that sign there, right next to the lake saying, hey, beware of the alligators and the snakes, right? So at the end of the session, I want to make sure that you don't have to fear the snake, right? That's what we want to accomplish here in this session. So let's get started with just giving you an overview. What is the tool set? Starting off with the traditional client-server technology toolbox. So if you want to build a traditional environment where you deploy your client on some machine and your server is running on another machine, typically you're going to talk through TCP/IP. What are your options? So we'll start off with what we call the Python SDKs. And as you can see, you actually have, wow, a bunch of options. It's not just a simple thing. We'll start off, we have PyODBC, which is like a very simple, low-level DB-API compliant interface for running SQL queries against relational backends. We have DB-API, which is, the name implies it, a DB-API compliant interface for running relational queries against a relational backend. We have native as an SDK, which is a low-level API which allows you to directly work with the globals in Iris in your Python scripts. And we'll be talking a bit more about SQLAlchemy. InterSystems Iris comes with its own dialect, which allows you to leverage SQLAlchemy with InterSystems Iris. SQLAlchemy is an ORM tool, an object relational mapping, which is basically a tool allowing you to model way more complicated data models than just simple tables, and then interact with them in an object way, not just from a relational perspective. We have a couple more tools we won't spend too much time on, at least in this talk here, which is an external language server. If you've been familiar with InterSystems for a while, you may know these as the gateways in the past. So these allow you to basically turn the communication channel upside down, and when you're inside Iris, you're writing your object script code or embedded Python code, you're able to call out to a Python script running or sitting on another system. So that's typically another way of the communication channel. And then we have PEX, which is an option for you to implement specific business hosts, so adapters or business services, business operations for the interoperability framework in the language of your liking. So PEX does support Java, .NET, and Python. So Python is just one of the many options you have here. As you can see, that's quite the list. So we're going to go through these one by one, and I'm going to give you some guidance on what these tools actually do, what the real use case is, and when you should be using which, and what it looks like. You're probably also seeing those little icons on the bottom right. So those will be popping up on many of my slides in a couple of variations. What this is intending to tell you is that in these environments, typically your logic is separated from the database. So the logic potentially runs on a different system than your database. That's what these two icons in the bottom right mean. Later on, we will see different variations of this. So keep an eye out for this. Let's start off with PyODBC. PyODBC is basically just a way to run ODBC through Python. The API for it is pretty low level, but DB API compliant, which is the standard in the Python world to run SQL queries. We've been supporting this for a pretty long time, and if you're starting today, I will always recommend you to not use PyODBC, but to use DB API. This is what the majority of the Python world is running on today. If you're running or if you're leveraging other libraries, they will always be asking for a DB API compliant implementation, so use the DB API driver. The only reason why you would want to use the PyODBC implementation today is if you have to connect to an older Iris version prior to 22.1, because DB API just got introduced in that version going upwards. So that's the only use case where I would tell you to use that, to use the PyODBC bridge. Installing it is pretty simple and trivial. Just it's on PyPy. Just pip install PyODBC, and then you just either point it to a DSN or you give it the traditional connection string, and then it's the standard API as documented. So pretty easy. If you want to know more about this, I have tons of code samples. I can walk you through this in a one-on-one session or at the Tech Exchange, but I'm not going to go into any depth in this session here. Jumping over to DB API, which is the more important version of this these days. DB API comes bundled with our native API as well, so that's just one wheel. How you install this is really simple and trivial these days. It's listed on PyPy, so you can find it under pypy.org. The package name is InterSystems-IrisPython. Since it includes more than just DB API, it also includes the native API, so that's why the name is a little bit different. So the only thing you got to do if you have Python installed in your environment, just run pip install the name of the module, and you're done. There's a little caveat here. So if you've been using the older versions of the DB API implementation, so that means version, that's the 3.x stream typically, then you can't just upgrade to the version that's now hosted on PyPy, because the older version was just a wheel you got from your Iris distribution, or you downloaded from the WSC software distribution page. So pip won't automatically feel that your local wheel is compatible with the wheel that's posted on PyPy. So the way how you got to upgrade this is you got to force the upgrade by saying, I want to upgrade to the version 5.1.2 or whatever version you want to upgrade to on the 5x stream. This is a one-time operation. Once you've done this, you can just regularly run just pip upgrade on that version and then you're done. But you got to tell the system that this is the same wheel and they're compatible. By default, pip won't upgrade a locally imported wheel with a wheel from PyPy. That's just how pip works. The code is not really that complicated. So this is like the typical boilerplate code that you will see in any DB API implementation. The only thing that's specific to us is the import statement. You're going to call import iris. That's the name of the package. And the connection string. Everything else is DB API standard and compliant. The connection string, really simple in this case. I'm just going to connect to localhost in this simple demo, but obviously you can pick whichever IP you want, since this is going through TCP IP. The port and the namespace you want to connect to. You provide the username and the password, your credentials, and then you run your connect method. Typically, the first thing you do is you get a cursor, and once you've got your cursor, you're going to start operations with the cursor, like running a SQL statement and running or looping through your result set. Typically, it's recommended to do this in a try-catch block. So everything you would want to do is actually should happen inside this try block here, right? You're going to handle all your exceptions here, and in the final statement, you would typically close your cursor and your connection. That's the boilerplate code you're going to leverage for any DB API implementation. So within this try block, this is the kind of code you would actually execute, right? So just executing a very simple select statement here. You just call the execute statement on cursor, pass in whatever SQL statement you would like to execute, and then you have a couple of options. Either you run something like fetch1, which is going to fetch like one individual row from your results set, and then you start iterating over those values, or you're going to execute something like fetch many, which is going to fetch multiple values in bulk. So that's way more efficient if you're running over TCP IP. If you're saying, hey, fetch me 100 messages at the same time, then you are looping over those 100 messages locally in your process, and once you're done, you fetch the next 100. That's way more efficient, right? Bulk operations. The other things that are typically important to understand is how you work with parameters. In Python, you have two ways how you handle these. Either you work with question mark style, so all your parameters are being represented by question marks, and then you pass in an array with the arguments in sequence that are getting applied to your question mark. So 1 is going to be your ID, and Jane Doe is going to be the name in this case. You just pass in the params to the execute method, and that's it. The other option, which is also pretty popular, is to use named parameters, the name style. So just use colons with the label name here, and then you don't pass in an array, but you pass in an object where the keys are the names that you presented in your query, and the values associated are the values you want to place into your SQL query. It's personal preference. There's no limitations to one or the other. You can do both as you wish. The second approach is a bit more descriptive. So if you have bigger teams, then typically those teams tend to use the named style, just because we can tell the system a little bit, you can provide a little bit extra level at the metadata level, right? But that's basically it. The final thing I'm going to mention here is that typically these result sets are scrollable. They're not just fixed. So if you pass in the attribute that you want to have a scrollable result set, you can actually position the cursor at any position within the result set. In this case, I'm saying I want to position the cursor to an absolute position of 3, which is going to position my cursor at row number 3. You could also use the same thing with a relative positioning, so you would move 3 rows forward in your result set. So that can be useful if you want to do cross-referencing or if you want to skip a couple of rows based on the data you've already read. Those are the most important APIs you want to be aware of. Obviously, there's a full documentation that you can take a look at our docs at intersystems.com, or you take a look at the DB API docs, since, again, this is an industry standard and there's nothing special on our side for this. Now going one level up the stack, SQLAlchemy, which builds on top of DB API, is a feature that's currently in active development, so something that we're expecting to release relatively soon. SQLAlchemy, as mentioned, is an ORM tool, an object relational mapper, which abstracts the SQL layer away from you, at least to some degree. And it allows you to build more higher level applications and modules and allows you to build your data model in a more descriptive way. That's not the only reason why you would want to leverage SQLAlchemy. Many libraries out there that work with result sets like data frames and pandas can be persisted in a database. And those tools use SQLAlchemy under the covers to persist the data sets. So SQLAlchemy just might be a dependency of one of the many modules that you're using in your application, even if you're not leveraging it directly. So you may come across it even if you don't want to build your own models. So it's worthwhile understanding what SQLAlchemy is doing. Installing is very simple. You need to install DB API and the SQLAlchemy Iris dialect. The dialect is also going to be posted on PyPy as soon as it's released. So the only thing you've got to do is actually do a pip install SQLAlchemy-iris, and that's it. It's going to pull in all the other dependencies automatically, and then you're done. Taking a look at the code, going to jump out of the presentation and actually walking through the code in the real IDE here. It's a bit easier to go through. I'll go through this in two stages. So SQLAlchemy comes with a very basic interface where you can just write your own SQL statements, which is pretty basic. So we go through that first. So this is a very simple Python script. You can see I'm importing a couple of things from SQLAlchemy, starting off with create engine, which is like the entry point in order to create a handle to your backend. And I'm importing a text field, which is important because every SQL query that you write actually gets wrapped inside a text component because you're actually working with string literals. So it's wrapping those. So let's get started with that. The first thing you always do is you create an engine, and the engine is basically your connection string to your backend. What's important here is that the first part of the connection string actually is the dialect you're picking. So in this case, I'm saying I want to pick Iris as my backend. If you would connect to Postgres, you would say Postgres here. Otherwise, you would say MySQL plus Postgres if it's Postgres compliant. So this is where you would pick which dialect you actually want to run. And the connection string afterwards then is specific to the dialect that you're picking. The one thing I'm going to mention is, and there are plenty of people who are not aware of this, is the second argument is pretty important if you're actually just getting started with SQLAlchemy. It basically tells the system whether it's going to echo everything it's doing onto the terminal into standard out. So by default, this is set to false. So the only thing is you're going to see from a run like this is the output you're printing yourself. But if you're setting the echo to true and you run the system, let me scroll up a bit here, then it actually prints out everything the SQLAlchemy engine is doing underneath. So it's going to tell you something like, hey, I'm beginning an implicit session. I'm running the statement, select hello world, and I generate it in this amount of time. This is my own print statement, and then I'm done, and then I'm doing a rollback. Okay, so actually you can read through this without printing it to a log. I mean, you can print it to a log as well if you want to, but it's really helpful when you get started and you want to understand what is the engine doing for you. So I recommend turning this on at least in your early days working with SQLAlchemy. It's really helpful. So let's take a look at the first thing we're doing here. I'm starting a with block, and I'm running the connect method on my engine object. And then I can start and use something like the execute method. So very similar to DB API, you see the same patterns happening. You're just connecting, and then you run execute. So what's important to understand here is how does SQLAlchemy handle transactions? So within this with block, my connection is present in this variable con, and I'm dropping the variable con right after the with block. So it's only valid within this with block. And once I'm done with this block, SQLAlchemy is automatically going to do a rollback, because a connect method is just an implicit session, and at the end it's basically going to roll back everything that's happening. So it's really good for experimenting and trying out everything. And if you actually want to commit something, like in the next example, I'm starting with the connect method as well, but at the end of my block I'm actually committing what I'm doing. If I'm not committing it, it's going to be rolled back. Since I'm actually executing a statement with a DDL statement, so I'm actually creating a table, I want to make sure that that table at the end of the block actually still is in the database, so I'm committing it. If I don't commit it, it's being rolled back, and at the end of my script, I won't see that table on the back end, right? So if you don't want to use the connect method and you want to have explicit commits, you can use the begin method, and the begin method is always going to commit at the end of the block. So you can choose in which kind of a transaction mode you want to be in as you configure your SQLAlchemy connection. There's a more advanced way of handling transactions with SQLAlchemy, which is the session object. And that's really useful as you start to modularize your application and you build a more complicated application tier, and you want to pass a session around to another piece of your application logic so that you can share transactions between different parts of your modules. So in this case, I'm creating a session that's valid within this with block, and then I can actually use this session to execute my statements, and I can use the session to run a rollback, to run a commit, and so on. And then I can take the session and actually pass it on to another module. So really useful, especially if you want to nest things. So sessions are the more advanced way of dealing with transactions within SQLAlchemy. So very simple way for the basics. But this is not really why you want SQLAlchemy, right? This is manually writing your SQL statements, so it's not really what you want it to do. It can do this, but this is not why we bought it. Here's an example that's more showing what SQLAlchemy actually can do, the ORM capabilities of it. You can see that my imports now include a bunch of things from the SQLAlchemy.orm package. And the first thing you typically do is you have to design the model that you want to work with. In relational speak, your tables. So the way how you do this in SQLAlchemy is you always start off with the base. That's your that's the best practice that you do. So that gives you like one element that's the root of your graph that you're going to build, and it allows you to pass this on to different parts of your application logic. And everything you're going to define is inheriting from base. So in this case, I'm only defining one object, which is a user, and it has 3 fields, an ID, a name, and a full name. I'm manually setting the table name to user account, something you can do, but you don't have to. I mean, SQLAlchemy can auto-generate the table name, but if you want to know what it is, it's useful if you set it yourself. For each of those elements, for these columns, just stating what kind of a type you want to set the column to. Is it an integer? Is it a string? Is it optional? Like in this case, if it's not optional, it's automatically required, right? If you overwrite the column type through the mapped column field, you can actually set whether it's a string with a maximum length of 30, 50, 100, or whatever. If it's in float, you can specify the precision and so on. So that's what you use the mapped column for. So going back to our code, the first thing you always do is you create your engine. That's always your starting point, the first line. And then we do something new. So we've defined our model, and now we have to tell our backend what our model actually looks like. We have to create those tables in the backend. So the first thing you do is you take the base. That's why we've started off creating the base object, and everything inherits from base. So we take all the complete metadata graph that's included of our base, and we're emitting it to our engine. So what this does is it actually walks through the whole graph, in this case just the user class, and it's going to check what are the tables, and does the backend already have those tables created. It's going to check the information schema profile. Are those tables existing? If they're not existing, it's going to create those tables through a DDL statement. If those tables exist and they're not compatible, like you've added a column, it's going to alter the table to add the additional column, right? That's what this first emit statement does. And then we're basically doing the same thing again with our transactions. You're going to create a session, and you start creating regular Python objects of the type user, right? So in this case, I created 3 users, SpongeBob, Sandy, and Patrick. And then I'm going to add these users to my session. And again, important, since we're working with a session, those will be rolled back at the end if I don't do something specific, so I'm going to commit it afterwards. So what's going to happen with this add all method is we're going to run an insert statement for all 3 of these objects, and they're going to be committed to the database. So now we have 3 rows in our table. So now actually we want to run a query and check what data we have in our database. So here's where the new logic steps in, right? Now we're not just plainly writing SQL queries. I mean, we could, but we actually want to ask the system, hey, I have objects, I have users. Show me all the users where my condition is the user.name is in this array. So this is a very specific SQLAlchemy syntax that, well, you got to learn if you want to work with SQLAlchemy. And you're just going to provide, in this case, the name SpongeBob and Sandy. So we're going to get back SpongeBob and Sandy as rows, but not Patrick. That's the result we're getting from this query. Obviously, those can become way more complicated. And once we're done, we're cleaning up. We're doing a delete statement for all of our users, and our database is clean. Okay. So this is like the most basic example of what you would be doing with a SQLAlchemy implementation. Jumping forward a bit. There are also options for running Python closer to InterSystems Iris. This is what you typically hear of as embedded Python. There are a couple of options that you can pick here, and you're seeing those symbols again here. These top options mean that your code, your logic, is actually running within the same process as your Iris process, while the option at the very bottom of this slide is an option where you're actually running a separate process, and it connects back into the database. So it's important to have that in mind. The first couple of options, I'm going to walk you through those with a couple of examples, is you can use the language keyword, and the default is object script in any class, to override that to set it to Python. So that means that the body of this class method is now not being interpreted as object script, but as Python. The other option is that you can use the %sys.python class using the import method to import a module that you've installed, a Python module, and interact with this module as or through the ObjectScript API. This is really useful if you're an ObjectScript developer and you want to quickly get a handle of a Python library. That can be really useful. The option where we're actually running a secondary process that connects to Iris is by running the Iris Python interpreter for a Python script that you've built, and that's leveraging the embedded Python package, which is import Iris, same package name, and you connect out to Iris. So what happens here is it actually creates a shared memory partition between those two processes. So it only works if you're running the Iris Python interpreter on the same machine or within the same container as your Iris instance is located in. And that allows you to basically write Python scripts and have a clear contract with your server-side code. You'll see an example of that. So here's an example for all three variations. If you're using the language keyword, it's basically like a regular class method in this case. You're returning a status and you're setting the language to Python. That's the only thing special you do about it. Everything that's in the body of this method is now basically Python code. So you just write your import Iris, in this case import requests. You probably wouldn't import Iris. Or you import NumPy, whatever the library is that you want to work with, and then you start interacting with that API. This method is callable from ObjectScript code. This method is callable from other embedded Python code. So you can mix and match, and that makes it really easy to use for simple demos and proof of concepts, obviously. The danger of this from an architecture perspective is that, well, you're mixing languages in the same class. That's a really bad thing to do. So use it for demonstration purposes, use it to quickly prove that something works the way you want it to work. But as soon as you actually want to productize it, I recommend you to actually build a clear contract and move your Python code into a Python script and call it the way you see it in a couple of slides. The other option is, as discussed, the %sys.python interface, which basically does the same thing as the code we've just seen, which is Python code, but now from an ObjectScript perspective. So we can import the requests package and then call all the methods that this package actually exposes and work with it as if it would be an ObjectScript library. Very powerful if you're an ObjectScript developer and you want to get or want to work with a Python library and get it integrated in your business logic. Very useful. But the downside is, well, you got to have a good understanding of both ObjectScript and Python. Because as you can see here in red, we're doing something weird here. We're calling what is called in Python a dunder, a double underscore method, which is like a system built-in method we're calling. In ObjectScript, that's like a % thing. So you can see that this is a not really nice syntax we have to call here in order to escape a dunder. So you got to be aware of all of these dunder methods, and you're recording them as a string, so the compiler is not really going to help you a lot. So it's error prone if you have a typo in here. And again, an ObjectScript developer is probably going to ask questions like, hey, what is this thing, right? So it's not ideal, but again, it's a good tool for just getting something started without thinking too much about it. What we are typically advising users to do is to use the third approach if you're going into a more, well, if you're becoming more serious of working with Python and Iris, which means you're building a clear contract between the two. So that means moving your Python code into a Python script file, a Py file, by itself, building your own module as if you would want to publish it on PyPy, and then just call it through the Iris Python interpreter. This way, you have a really, really clear contract. The Python developer knows exactly what he's touching, and you can prescribe the entry point through your main arguments and make it callable. Or you call directly to InterSystems Iris through, let's say, DB API or whichever means necessary to get the data that you care about. So that gives you a really clear contract, and it separates out Python code from ObjectScript code, and you have a clear line of responsibility. So that's typically what we recommend you to do. And there's a couple of upsides to this as well, we'll see in a bit. For embedded Python, you got to configure the system and let it know where your Python runtime lives. So since 24.1 and 2, we support something which is called the flexible Python runtime. So that means that you can pick the Python runtime, or you can configure the Python runtime that InterSystems Iris is going to use and leverage. So that means that specifically on the Windows system, which doesn't come with a Python runtime by default, you got to install the Python runtime first, and then point Iris to wherever you've installed the runtime. If you're running on Unix environments, which come with a Python runtime by default, you don't have to do anything to get started. We will just pick up the operating system version. But sometimes you may not want to use the version that comes with the operating system. You may want to use another version. You can install this in a path of your liking, and then point Iris to the new version that you care about. So instead of running 3.8 on Red Hat 9, you can run 3.11. So that's the idea here. The only thing you got to do is configure the variables Python runtime library, which is the path to the interpreter, and Python runtime library version, which is the version number you want to run, like 3.9, 3.10, 3.11, for us to pick it up. That's something you can configure in the CPF file and the configuration file, or if you want to, also through the management portal, if you're more a visual person. Moving up the stack a bit to interoperability in Python. So if you're a fan of our interoperability framework, obviously you can leverage everything we've talked through so far. In addition, in all the editors, like the DTL editor or the BPL editor, by default those expressions are ObjectScript. You can also turn on the language keyword there and say, hey, I want to write these expressions in Python. Either you do this globally on, let's say, the whole DTL, and you say all my expressions are now Python, or you can do it on an action per action case if you want to. Not necessarily something I recommend, because again, you're mixing languages, so ideally you do it consistently. But sometimes there are edge cases where you already have a DTL that actually does the job well, but you just want to integrate one statement in one line. So, but still consider it a hack. I prefer to be clean here. And then there's another thing you should be aware of, which is interoperability on Python. That's a community project that's listed on OpenExchange. It's a very popular project which allows you to build business hosts in Python as Python scripts. So the way that we've just talked about, make sure that your Python code actually is in a script and not embedded somewhere else. And the basic concepts here are really, it's a Python-centric approach, so not Iris-centric, but you're thinking like a Python developer. And you build your host, adapters, messages directly in your PY files, produce a wheel out of it, and run those. You can define everything that you do in ObjectScript development as well, so parameters, arguments, those can be defined, and you're going to implement all the callbacks, like on process input, same way as you're used to it. And the only thing you got to do in the end is you got to generate the server-side code so that we can actually hook into the PY file and get this married with your items in your production. Good news, I mean, right now this is a community project, so it's not officially supported by InterSystems. We are working on a variation of this that we're planning to release later this year, which is officially supported and follows the same basic concept. So here's an example of what that's going to look like. This is one py file which basically describes a full production. And as you can see here, I'm describing a message up front here with a name and an amount as an integer. I am building my own custom adapter, which is inheriting from an inbound adapter. I am implementing those on-task methods that we all know if you've built with the framework before. And I'm building my own custom business service which is using the adapter that I've just built, all in the same file. You just register it once, and then it pops up as an element that you see on your regular visual screen on your production. So a very helpful tool. That's a listing of the majority of things you care about. Let's talk a little bit about tooling. If you write code, you want to be able to debug it. Who doesn't? I mean, ideally, we don't want to, but what's important to understand is, and that's the reason why I've always gave you those little boxes here, as long as your Python code runs in a process of its own, you'll be able to debug it in an efficient way. As soon as your Python code runs embedded within the same process as Iris, there's no simple and trivial and consistent way of debugging your code. So one of the many reasons why we are advising you to build an architecture where your Python code runs in its own process through shared memory. The way how you set this up, and I'm going through this in an example through Visual Studio Code, since that's the IDE we also do our object script development in, is really simple. You just need Visual Studio Code, the Python interpreter, and you want to install the Python extension. So those are two things that typically come in a package. The Python extension by itself, which makes the IDE Python aware, and the Python debugger, which allows you to actually debug your code, which is based on PyDB. There are two use cases for debugging, either local debugging, which means you're debugging your code on the system where InterSystems Iris runs. This is this case. And you will need what's called a launch.json file to configure your debugger for those scenarios. And going fast forward here, everything that's non-red is the standard configuration of debugging any Python file. Everything that you see in red is like setting up special environments so that the debugger is aware of the location of where our Iris Python interpreter lives and where it needs to load the modules that we're actually referring to. So which username, password are we using, which namespace want we connect to, and where does your Python modules live? And that's typically the Python path of your Iris instance. What's a bit more complicated is remote debugging. So I'm going to skip the demo for this, but I want you to be aware that this is possible. If you want to debug code that's not actually running on the system you're on, but it's actually on a remote system, so typical use case for this would be you're running a container on your local machine which runs your code. That's also remote debugging if Visual Studio is running outside of your container. It's physically a different machine, right? It works a bit, the setup is a bit more complicated because you got to start the debugger actually on the remote machine, and then on the machine that's local, you got to start up and attach to the remote debugger. So you got to expose a port, and the way how you set this up is you're going to not use the file mode of your debugger, you're going to use the attach mode because you want to attach to another debugger running on another system. And here's the magic, you want to point it to the port that the other debugger is using. And here's the thing that may not be obvious. You have to provide two directories. The first directory is the directory which contains the files that you're about to debug on your local file system, while the second path is containing the folder on the remote machine, which includes or which holds the source code that you're debugging. What's important is the remote directory actually contains the code that's been executed, and you need a copy of the same code on your local machine so that Visual Studio Code can actually show you the code that's being run on the remote system. So those two need to be synchronized. That's something you need to be aware of. That's how remote debugging works in the Python development environment. Okay. One more thing to mention, and then we're done. Setting up virtual environments is something that's really important as soon as you start becoming a bit more enterprisey. What this provides to you is it allows you to sandbox your code. So you don't pollute the global environment with all the import statements that you're doing, and you're protecting yourself against against everybody else who's importing modules. So you're sure that you're running in an environment that's always reproducible, and you're protected against side effects. There are two choices in the Python world. One is VN for virtual environments that's built into Python. The other one is Conda, which typically is a paid service. The way how you set this up is pretty straightforward. In Python, you just run a venv command for a directory. It will create this directory, in this case, my folder. And what basically happens is it takes the current interpreter that you're running and creates a copy of this interpreter in this folder, including a structure of all the imports that you're going to do. So whenever you activate this environment, this is what's going to be used to start that process, instead of the global interpreter. What's useful to understand with these virtual environments is once you've activated a virtual environment and you run a pip install, it's not going to install the module in the global environment. It's going to install this module inside the virtual environment only. So once you deactivate that virtual environment, the module is unloaded. It's not there. You don't have it, right? What's important for making this scale is you don't want to run these pip install methods all the time by yourself manually, but you want to be able to ship your application with like a metadata file saying these are my dependencies, these are my requirements, so that everybody can run your module in a safe way without you having to tell them, oh, you need to run pip install SQLAlchemy. Otherwise, this won't work. So the way how you do this is you create what is called a requirements.txt file. And this file lists all your requirements. You don't have to build this manually. The way how you do this is you run the freeze command, which basically creates a list of all the modules that have been created in your virtual environment. And if you just point this to a requirements file or you copy paste it into a file manually, if you're on Windows, then you're good to go. That's the only thing you got to do. And once you want to start this and actually make it, actually want to install it, the only thing you got to do is you run the install statement with -r pointed to your requirements file, and then you install everything that's in that file. Or pip is going to just check if there are any updates you want to run. Okay, that's everything I got for the toolbox. So here are the regular slides you've probably seen a couple of times already today. We have a couple of EAPs. If you haven't seen that, take a snapshot of the QR code and sign up for the EAPs you care about. Please, in the cBand app, do provide feedback about what you liked about the sessions, what you didn't like, and how we can make those sessions even better. And if you want to learn more about Python, we do have another session today at 5:55, or maybe it's 5:30. Maybe I didn't. I'm not sure. I got to double check. It's right next door about productive data science, so more focus on the data science approach of leveraging Python with InterSystems Iris. We have a session on Wednesday going through all the tools that you can use with a strong focus on Visual Studio and Python tooling. And we have a couple of tech exchange sessions on interoperability you should take a look at. And we have a permanent Python roundtable. If you go at the tech exchange, right at the very end on the right side, there's a Python table, which is manned by Python experts. And you can just come by without making an appointment and just ask your questions or show what you've built, and get some feedback on that. That's everything I got. Thank you from my side. I hope you enjoy the rest of the day, and we all see each other at the Ready Games tonight. Thank you very much.